Hello friends, this is Bunoti Agre, student from Mountains of the Moon University. Today's lecture we're gonna have linear regression on how to optimize the model depending on the ordinary way of doing it. So we're going to see how we can hypertune the model by giving it different parameters to see that we improve our accuracy. So this is the dataset. The dataset is all about the air pollution within a given area. This dataset was collected from different cities of India. So we have air pollution, temperature concentration, then population distribution. This is how people are distributed within a given city. Then green spaces, those are some of oasis and some gray matter. We have age distribution, that is obvious. Then income level, then hospital admission. So here our independent variables are going to be air pollution, temperature, population density, green spaces and age distribution. Then income level. We want to see how these independent variables are correlated with our target variable, which is hospital admission. Remember, the air pollution can lead to various respiratory disorders like asthma and lung cancer and so forth. So these are dependent variables which are going to bring the hospital admission is to either increase or decrease. So we are going to train the model to see that when it is given certain data related to air pollution, temperature concentration, population density, then green places, spaces, then age distribution and level incomes, can it be able to predict whether the hospital admission is going to increase or decrease. So this model is going to help majorly the medical researchers and environmental regulators to plan for the future. So I had to import necessary libraries to read my data frame into pandas. So I had to load the data set which I had already on my desktop and I have stored it in the CV format. That's why we have this file extension .csv. Then I had to display the first part of my data set to see what I'm going to do. Then I had to identify the independent and target variables from the data set. Then I had to visualize some of the independent variables, which I said print independent variable, which is X. That is what favors how many number of people will be admitted in the hospital depending on the given data, which is air pollution concentrated within the given town, then temperature concentration, population density, how people are distributed in a given town, then green space, those I told you are oases and green pastures within, then age distribution, that is obvious, then income level, that is status. I had to identify also target variables, but by changing them from data frame into numpy, which is np.array, so that my Jupyter compiler can read the data set. Next step, I had to check whether my data set contain null value, that is missing values. So I had to call the library data.isNull sum. So I had to get the sum of the values which are missing, but good enough, I found when there are no missing values, which calls for next step. So I had to visualize how hospital admission are distributed, how independent variables are distributed by using a subplot. Then I had to use the model which is multiplot lib.pyplot Then I got the library, which is PLT. Then I had to set for the settings for the figure and subplots, that is figure. This is 2 by 3, meaning I have 2 rows and 3 columns. So to distribute my subplots, then the figure size, that is the length. Length I have 15 centimeters, then width I have 10 centimeters. So I have to visualize the concentration of temperature in degrees, concentration of distribution of air pollution in megapixels, concentrations. Then I have to visualize the population density by using bin 30, that is interval within a given histogram. So I had to visualize it down here. So this is distribution of hospital admissions within the frequency. Then this is distribution of air pollution within a given sequence, but air pollution here is measured in megapixels in concentration. Then temperature distribution of a given cities, how is it distributed. Then here population density, how people are spread within a given area. Then green spaces within particular, how are they distributed, that is in percentage. Then I had to get the scatter of air pollution vis-a-vis hospital admission. So since my target is to train the model to predict how many numbers of people will be admitted depending on the concentration of air pollution, temperature and what? Age, population density, green spaces. Remember, these things affects the livelihood of humanity. So they also determine how the model will detect the mode of accuracy of this model whenever given the data. So I had to split my data into training and testing. So I had to use the module called scikit-learn.model selection, import library code train test sprint. So I had to sprint the dataset into train and test. So that is x train, x test, y train, y test is equal to the library code train test sprint. What am I splinting? X and y. Testing size is 0.2, meaning 20%. Then the 80 will be for training. Then random state, that is number of iteration on how the model is going to select the variables randomly by iterating. So I had to build the linear regression model from a model called scikit-learn.linear model, import library code linear regression. So I had to fit this model to fit my dataset within the range. So I had to say model.fit the model, which is linear regression dot fitting what? X and y train. So when I run this, I had to get the model being built. So from that I had to predict the y values on response to x tests. Remember, after training the model, I trained it using that 80%. So I am bringing this 20 to test whether the model has learned these values. So I got certain value to test whether this model has learned something. So it had to predict for me the y values depending on x values provided. So this is y predict. So I had to visualize it. That is y predict. So managed it to give me some values here, which is also good. So I had to evaluate the linear regression model performance from scikit-learn matrix, import mean absolute error, mean squared error and error to score. So I had to define it. So I had to abbreviate them. MAE is equal to, okay, so my here my after computing, which I get the mean absolute error. The mode less the mean absolute error, it means the model has learned something. So the values here I can see I have R2 square, which is model accuracy, it is 1, meaning 100%. So when given that data in very appropriate manner, it means that we are going to get the model which is good for prediction. So here mean absolute error we have 1.17, mean that value is at least slightly small, meaning that model is good for predictions. Then intercept and coefficient. So this model can be used for health science to predict, when given certain data in a given city, to predict how many numbers of people will be admitted, and they plan for the future. So that, remember, the time of COVID-19 we encountered various problems just because we didn't have these modules. Thank you for listening. This has been part 1. So part 2 will be on model optimization. Thank you very much. May Lord be with you. This has been Dumont Agri, a student from Mountains of the Moon, pursuing the bachelor's degree in computer science, year 1, semester 2, linear programming under machine language. Part 2 will be optimization of linear regression. Thank you very much.
I want to teach me how you do that. You were teaching it.
Aye, kali kukola.